just have to be able to identify the phase difference, because the phase difference comes into the formula both for the position of the object and in the velocity of the object. All right, so how to find the phase difference? So I drawn here a general case of a sine function, or a function that has the same shape as a sine function, but you can look at it in two ways. It's either being pushed this direction or it's being pushed that direction. So you can kind of identify that if I measure from here, it would be a perfect sine function from here, or it could be a perfect sine function from here. So that means that we have kind of two possible ways of finding the phase difference. So there's multiple answers to the problem. But I start off by having this formula from the formula booklet. But what I want you to do is think more about the function I have written beneath it. And if you pay close attention, you see the only difference from this one to this one is that I here have factored out omega. So I've factor out omega so that I get omega times t plus the phase difference divided by omega. And the reason why I do that is because this phase difference, which we call this Greek letter phi, this one here, Greek letter is phi. This cannot be read directly from the graph. But this size here, this O phi divided by omega, can be read directly from the graph. That's why I like to write my function in this way, because I can read x0, I can read that directly off the graph. I can calculate omega by finding the period, and I can read directly what phi divided by omega is directly from the graph. And there's one way I like to think about it, is that here, if I look at this part here, I start off by saying I start off at point A, which is a negative number. I don't care too much about that. But from A and from the rest on, I get a sine function. And so I look at the value here of A. I don't care about the sign, I just look at the A. So in this case, if I look at this one here, I can say that phi divided by omega is equal to that value A. Yeah?
Could you say that phi divided by omega is equal to B as well?
Almost.
Plus.
If I read off that value, phi divided by omega is equal to minus B.
What's the difference?
It's just the way, in what direction there's no difference. If I insert phi divided by omega equals to A, I get the same function as if I say phi divided by omega is equal to minus B.
So
I get the same function. I can do both ways.
Okay.
Yeah. So basically, just the difference is from here. If I want to make this a perfect sine function, I need to shift this in this direction here. If I want to make this a perfect sine function, I have to move it in this direction here. It has to be the direction I have to move the graph to make it into a perfect sine function. That's why there's a difference in sign. Positive here and negative here.
But why do you have positive there and not?
It's easier when I do it with numbers. Maybe we can see when we use numbers.
Okay.
So I'm gonna explain how I do it. So basically, what I tried to say that we should look at the graph, writing the function like this, and we should look for where it intersects the x-axis and create then a perfect sine. So I will just try to do an example here. Let's see if I can come up with a good explanation of it. I am positive, not 100% positive, but I have some confidence that I will be able to explain it. So we start off simple. So we want to find the function describing this graph here. So start off with a simple one. What is an x0? Isha? Yeah, 0.05. Good. What is omega? How do you calculate it? What do we do to find omega? Emily?
2 pi divided by t, so 2 pi divided by 2?
Yeah, that's a good question. What is the period here?
2.
1. No, I can't remember because it's like
Two.
0. What?
Yeah, 2.
Yeah,
How is it 2?
because it's the distance, or it's for the period is defined as the time taken for the two oscillations. Or
So-
whether it's
No,
the-
1.
Two-
It's from
2.5?
minus, no, it's from minus 0.5 to 1.5.
Yeah, so
Which is 1.
Which is 2.
Which is 2.
Which is 2.
Oh, yeah.
Good. Period is 2. So omega is equal to pi. All right. So I now have to deal with this phase difference. So basically my idea here is that I start writing off x as a function of time, and I start off by writing 0.05 sine to omega, which is pi. And now I just start with a bracket writing t. And here I will then insert the number I can read directly off from the graph. So it's going to be now either minus a number or plus a number, depending on how you look at it. So one way to do it is to see that, okay, what 2 points on this graph are interesting in terms of finding the phase difference. You want to make it a perfect sine function. Where can you look at a function to?
At the start.
At the start? So here you mean that point here?
At 0.
Here?
Yeah.
So start at that point here. So that means that from 0,
Oh no.
here you can start to think that maybe I can describe this part here.
Yeah.
And try to imagine that I will pull this back to the beginning. So I want to make my time 1.5. From 1.5 seconds and forward, it will become a sine function. So I want to pull this back 1.5 seconds. Do you agree that from here and so on, it will be a sine function?
Mm-hmm.
So I just want to make this my time 0.
But minus 0.5 is also.
Yeah, but now I focus on this part here.
Alright, okay.
So that means that by pulling it back, I have to do minus 1.5 here. Right, so now I ignore that point. I accept this point here. But I just think of the way I that, okay? I start off here, but from here on, I can now think, okay, I want to put time equals 0 to that point here. So if I want to make 1.5 second, 0 seconds, I have to subtract 1.5 second.
So how do you choose the value 1.5 seconds?
Because from here on, here it starts with being in equilibrium and in positive direction. From here on, it has a shape as a sine function.
But it has the same shape from
Yeah, I agree.
But can we not just do plus 2.5 also?
Yeah.
Oh, so it's two.
Yeah.
options. Oh,
Yeah.
okay,
Yeah. And very good, Lamia. And we can do both possible.
It's t plus 0.5.
Yeah.
You did pi plus 0.5.
I was nowhere close. I was so pleased with myself. T plus 0.5, like this. Those two are the exact same thing. Both of them describe that function equally well.
Do they result to the same thing?
Yeah.
So
If you go into GeoGebra and write those two functions, they would completely overlap.
Okay.
So those two are the same function. They describe the same thing.
So do you have to write both answers?
No.
You just use one.
Yeah, you choose one. Yeah.
This is just translating the graph, basically.
Yeah. It's transformation. So you have transformation in math, right?
We do.
It's basically just transformation. Shifting it from right to left with a positive sign or negative sign. It's basically just a transformation of graphs. So here I kind of think in terms of physics, if I started my clock 0. seconds before, it would be a perfect sign. It would start off at equilibrium. If I started my clock 1.5 seconds later, it would start at equilibrium.
Yeah.
So then I do minus or plus, depending on what direction. So I just think to the right, negative, to the left, positive. Yeah.
And since you know both omega and A and B,
Yeah.
you can find the phase difference.
Yeah.
But isn't the phase difference different depending on which one you use?
Yeah. Which is
then-
still no problem.
How do you choose?
You choose.
It doesn't
And
matter.
okay, and
It
what-
doesn't matter.
Okay, and why isn't it a problem that they're different depending on which one you take?
Because they would give you the same answer. Yeah.
That makes no sense for me. In my head, because if you do omega times A, it's not.
Yeah, but it's the same
as
thing
omega
here.
times
It
minus
depends.
B.
It doesn't matter if I'm pulling it back or pulling it in what direction. Depends on what direction you're pulling it.
I know, but to find the phase difference,
Yeah.
it won't be the same if you do omega times A than if you do omega times minus B.
No, it won't be.
Well, then
But if
the
I
phase
accept,
difference is not the same.
if I accept that I have two different times, why can't I accept I have two different phase difference?
But isn't the phase difference something that's like?
No, two different phase
So
difference.
what do you use the phase difference for then?
Just to shift it. Yeah.
Like, what does it mean? Phase
And then I'll
difference.
make
It just means the shift you have in the graph.
Basically where the
Yeah, where the graph starts.
yeah, where the y-axis starts. Because sine function is
Well,
continuous.
yes,
so
but
it's
it's-
where-
But then it's the same as A or B. Like,
Well, here you use two signs. Two different.
The phase difference here will be different than phase difference
Is
here,
that the
but
same as, like,
you always have two different values. Two
different.
different phase differences give the same result.
It's not because the
I
sine
don't get the
Yeah.
use of phase difference because,
Do you accept this one?
yes,
Yeah.
this makes sense. to
Yeah.
me, yeah.
Yeah, but that's good. That's good. All right. Now we're going to find the phases. Now everyone have to kind of pay attention. All right. So choosing this is okay. This is alternative 1. Alternative 1. We have now that x sine 2 pi t minus 1.5 second, right? That's how I like to do it. But of course, they could ask you, what is the phase difference? Then they want, yeah, so basically you just multiply. Then you write it, go from here to here. So you write 0.5 times sine 2 pi times t minus 1.5 times pi, or here 3 pi divided by 2. Right. So in this case, the phase difference, if asked for that, then the phase difference is minus 3 pi divided by 2. So that's alternative 1. Yeah.
Because that's what my question originally was like, do we give our answer as like the phase difference is 0.5 in the in the first two?
Yeah.
I was like, is it just phase difference minus 1.5? But then you have to factor in the fact that
Yeah, that's kind of the way they like it, yeah. But I think they would accept this answer as well. And they would accept this answer here. And they would accept this answer here.
the phase value,
Yeah, phase difference, yeah.
phase difference.
Yeah.
Okay, yeah.
And alternative 2 is basically just look at the first one, the second one, t 0.05 sine pi t plus 0.5 t 0.05 sine 2 pi times t, and then 0.5 times pi is just plus there. And so the phase difference here would be pi over 2. So it doesn't really matter which one you use here, if you use this one or you use difference. Probably the IB would written this one because here the phase difference is positive. Yeah.
Why cannot we read the first one with the arrow?
Yeah.
Or why can't you read that directly from the graph?
This one here.
Yeah.
Yeah, and that's the problem. That's the reason why that is simple. What unit do you have on this x-axis?
Seconds.
Seconds, right?
Yeah.
That's time. Here it's displacement. That's in meters.
Mm-hmm.
Omega is radians per second. So omega times t, that becomes radians.
Yeah.
And phi has the unit of radians.
Mm-hmm.
There's no radians on the graph.
I thought radians wasn't strictly set a unit.
Yeah, but then okay, but it is this one is radians, and this one is a radian. That's an angle. Omega times t is an angle in radians. Phi is an angle in radians. But we're looking at displacement versus time. But if I take an angle divided by, if I take radians divided by radians per second, I get the unit of second. So this one here, this one has the unit seconds. And this one here has, of course, unit of seconds. So that is basically, that's a problem with sine functions. The sine functions are very mathematical, but we're dealing with physics problems. We're dealing with displacement and time. We're not dealing with angles here. So from a physics standpoint, I think this one is a bit easier to understand because I can read off the values directly from the graph. So I can't read off the phase difference directly from the graph, but I can read off directly from the graph what is the phase difference divided by omega is. That's why I like to start off by writing x0 times sine times omega, then do the brackets, and then write t minus or plus either that value here or that value there. And once I've done it, once I have this function here or this one here, I can then pretty easy make my velocity function just by multiplying it with omega and changing sine to cosine. When going from x to v, I don't really have to think about what the phase difference is. I just keep it when I write the cosine. It doesn't get involved with what happens here. So I think this is what we need to practice on. So now you can test for yourself. So, okay, what would the answer? What would be in the mark? What would be the answer the IB was looking for? They would probably choose this one here because it was a phase difference of which was positive. They probably would have given you this to be the answer.
Would have been wrong if you put the answer in negative?
No.
Okay.
No, so it doesn't really matter which one we choose.
No. It does, really.
So you equal marks.
Yeah.
Even if they offer a positive based on.
Yeah.
And you give them a negative one.
Yeah, because you can argue that sometimes it would be more correct to have a minus because the phase difference is going to be either from 0 to 2 pi.